Our next unit, Chapter 9, is on adding and subtracting integers. We're going to look at 9.1 and 9.2 together. They're both on adding integers. They're just different ways, and I'm going to show you both of those. At the end of this lesson, you will be able to add positive and negative integers. The first question, of course, is what is an integer? An integer is a positive or negative whole number. It's not a fraction, it's not a decimal. So 21 would be an integer, 2 would be an integer, 2 billion would be an integer, as well as negative numbers. So negative 3 or negative 2048. These are all integers. One way of dealing with integers is to use integer chips to add and subtract them. In the textbook, the integer chips are red for positive and blue for negative, but the ones we use in the classroom are red and yellow, so those are the ones I'm going to use in this lesson. The combination of a positive integer and a negative integer is called a zero pair. I want you to pause the video for a moment and in your journals explain why you think this would be called a zero pair. Now I want you to picture this box as sort of our mat, and what we're going to do is anything that we put on here, we're trying to find the total balance of that space. So if I have 2 positive chips and 2 negative chips on this mat, what's the total number, what's the total value of what is on the mat? Take a moment, write it in your journals. Since we know that 1 positive chip and 1 negative chip equals a zero pair or equals 0, we can actually rearrange these chips, making 2 zero pairs, each of 1 positive and 1 negative, equals 0. So the balance on here is 0, and we can write this as positive 2 plus negative 2 equals 0. Positive 2 and negative 2, therefore, are called opposite integers. They're the same numeral, but they have different signs. I want you to predict the sum of any pair of opposite integers and explain your reasoning in your journal. We can use integer chips to figure out how to add 2 integers together. Positive 5 is 5 red chips. Negative 3 would be 3 yellow chips. Now if we take these and we make as many 0 pairs as we can, we end up with 3 negative chips, 5 red chips. Now we know that these all equal 0, which leaves us with just 2 positive chips left over, which means that the sum, when we add these two together, the sum of this is positive 2. I want you to use this same strategy to solve each of the questions that are here in your journals. If you don't want to use felts or pencil crayons, you can write your positive chips with a circle and a plus in them, and your negative chips with a circle and a minus in them. And then I want you to write this out as an addition statement, which is what this is here. Pause the video and then come back. Once I've put my integer chips into 0 pairs, I can draw a box around the total that is left over and use that to write my addition statement. A couple of things you may notice. When we're dealing with 2 positive numbers, as we are in this first one, it looks like a regular addition problem. 2 plus 3 equals 5. And that's because usually if there is no visible sign, positive or negative sign, we assume that we're dealing with positive numbers. Now, because this is an integer unit, whenever you are using integers in the assignments that we're doing here or in our test, I will expect you to have a positive and negative signs in them. The other thing you should notice is that when one number is bigger than the other, and they're different signs, like here we've got positive 4 and negative 2, the higher number provides the sign. So positive 4 plus negative 2, that negative 2 cancels out, in a sense, 2 of the positive 4, so we're left with positive 2. It works the other way as well. When we've got a larger negative number than we do a positive number, that negative number cancels out the positives and we're left over with negative 3. You can also use number lines to help you add positive and negative integers. If we're trying to model positive 2 plus positive 3, we can start at 0 and go to positive 2. And then on top of that, we add another positive 3. So 1, 2, 3. And we end up at positive 5. Likewise, adding negative 4 plus negative 2, we start at 0, we go down to negative 4, and then we add another negative 2 on top of that. Notice that when we are adding, or when we're looking at positive numbers, we are going to the right. If we're looking at negative numbers, we're going to the left. And we can see that negative 4 plus negative 2 equals negative 6. If our numbers are different signs, it really doesn't change what we do. We start at 0, we have positive 3, so we go up to our right to positive 3, and then negative 2 goes to the left, so from where we ended up, we go back 2 points, and we end up with positive 1. Likewise, if we're starting with a negative number, we start at 0, we go down to the left, negative 5, 1, 2, 3, 4, 5. And then that's where we end up. We're going to add 4 on top of that. So we start where we ended up, and we go up 4, or to the right 4 in this case, and we find that our answer is negative 1. I'd like you to copy these examples into your math journal and then describe how you can use a number line to add two integers, whether they are two positive, two negative, or one of each. And remember, of course, that your number lines don't just have to go left and right. They can also go up and down, as in this example here. The key ideas for this lesson are written here, and you need to copy them into your journal. First of all, you can use integer chips or arrows on a horizontal or vertical number line to represent integer addition. A zero pair, which includes one positive 1 chip and one negative 1 chip, represents 0, and the sum of any two opposite integers is 0. For example, positive 7 plus negative 7 equals 0 because it makes 7 zero pairs. When using a number line to represent integer addition, the direction of the arrow indicates the sign. If the arrow is going up or to the right, it's positive. If it's going down or to the left, it's negative. And the length of the arrow shows the value of the numeral in the integer. Your assignments for this week are written down now. The red is required for everyone. The yellow is optional. If you get all of the practice and all of the apply questions correct, you should do the extend. Come and see me if you have any questions.